Is Westerlund 1 a star cluster that defies the laws of physics? Or is there a hidden force holding it together? In this video, I'm going to give you the complete picture. You'll learn exactly why astronomers first became obsessed with this mysterious cluster, and what a new study has uncovered that makes it even stranger. Then, we'll break down the biggest scientific puzzle surrounding Westerlund 1, from its impossible shape to the stars that refuse to follow the rules. Finally, we'll explore the leading theories that might explain its bizarre existence, including whether it could be hiding undetected black holes or even interacting with dark matter. By the end of the video, you'll understand why this star cluster shouldn't exist, and yet somehow it does. Buckle up, because this one is going to change the way you think about the universe. Star clusters aren't supposed to behave like this. Normally, when a massive star cluster forms, its structure is fairly spherical. A dense core surrounded by stars gradually thinning out toward the edges. That's how gravity works. But Westerlund 1 defies this simple expectation. First, it's not spherical, it's elongated. Astronomers have found that instead of forming a round shape, WD1 is stretched out like an oval with an eccentricity of 0.71. To put that into perspective, if a typical star cluster is shaped like a perfect ball, WD1 is more like a flattened football. This degree of elongation is highly unusual and suggests that something external may have influenced its shape. Perhaps it interacted with another massive object in the past, or maybe its formation conditions were so extreme that it never settled into the expected round shape. Second, it is subvirial, meaning it should be falling apart, but it's not. Star clusters should ideally be in virial equilibrium, a balanced state where the gravitational pull inward is countered by the outward movement of stars. But in WD1, the stars aren't moving fast enough to counteract gravity. In simple terms, this means the entire cluster should be expanding and dissolving into space over time. Yet, against all logic, it has remained intact for over 10 million years. This is like watching a sandcastle on a beach withstand massive waves without crumbling. It just shouldn't happen. Third, the most massive stars in the cluster aren't where they should be. In almost every other star cluster, there's a process known as mass segregation, where the heavier stars sink toward the center over time due to gravitational interactions. This is the same principle that causes larger rocks in a jar of mixed sand and pebbles to settle at the bottom when shaken. However, in Westerlund 1, this process appears to be weak or even absent. The massive stars are scattered throughout the cluster rather than concentrated in the core. This suggests that either mass segregation hasn't had enough time to happen, or something about the cluster's environment prevented it from occurring. All of this raises an enormous question. How did this cluster form, survive, and keep its shape in a way that seems to break every rule we know? To answer this, we must look at the fascinating discoveries made through detailed observations of Westerlund 1. One of the first major questions is, how big is Westerlund 1? The short answer, it's massive. It contains at least 75,000 times the mass of our Sun, making it one of the densest star-forming regions in the Milky Way. To put that into perspective, if our solar system were placed inside WD1, it would be surrounded by thousands of gigantic, young, and extremely bright stars. However, there's an issue. Astronomers don't agree on its exact distance. For decades, estimates placed WD1 at around 4,000 to 5,000 light-years away, but newer measurements from Gaia and Hubble suggest it's closer, between 2,600 and 2,800 light-years away. This might not sound like a big difference, but it has huge implications. The farther away an object is, the more massive it appears. If WD1 is closer than we thought, then it is less extreme than originally believed. But if the older distance estimates are correct, then it is even more puzzling and massive than expected. There is also a major debate about its age. Some studies suggest WD1 is only 3 to 5 million years old, while others claim it is closer to 10.7 million years. If it is younger, then it might still be evolving, but if it is older, something has allowed it to remain intact for an unusually long time. What's even stranger is that its stars are losing mass faster than expected, meaning they are evolving unusually quickly compared to stars in other clusters. This rapid evolution has led some scientists to propose an intriguing theory. Westerlund 1 could be a hidden black hole factory. Because WD1 is packed with high-mass stars, many of them are likely on the path to becoming black holes or neutron stars. Some astronomers suspect that black holes may already be lurking in the cluster, but they remain undetected. This could be an important clue as to why WD1 is behaving so strangely. Perhaps a large number of black holes formed early on and were ejected from the cluster, disturbing its equilibrium. Astronomers have put forward several possible explanations for WD1's bizarre behavior. One theory is that it formed in an extreme environment, possibly in an area with unusually high gas pressure, which altered the way its stars evolved. Another possibility is that its gas was expelled in a highly unusual way. Normally, young star clusters lose their surrounding gas quickly, but in WD1 this process might have been slower, allowing it to maintain its structure longer than expected. But perhaps the most exciting theory is that an unseen force is holding the cluster together. While this might sound like science fiction, some researchers have speculated that WD1 could be interacting with dark matter in an unusual way. Dark matter is thought to make up most of the universe's mass, but it remains invisible and mysterious. Could it play a role in stabilizing this cluster? It's an idea that remains speculative but fascinating nonetheless. What is clear is that Westerlund 1 challenges our understanding of how star clusters form, evolve, and survive. It is a laboratory of extreme astrophysics, offering insight into how the most massive stars in the universe live and die. In conclusion, Westerlund 1 remains one of the biggest mysteries in modern astronomy. It defies gravity, challenges our theories on mass segregation, and raises questions about how black holes form in massive star clusters. Its existence forces us to rethink what we know about the evolution of stars, clusters, and even galaxies. Could Westerlund 1 be the key to unlocking new secrets about the universe? Only time will tell, but one thing is certain. This is a star cluster that shouldn't exist. But it does. Thank you for tuning into Amazing Space. If you enjoyed this update, don't forget to subscribe and hit the notification bell for more cosmic discoveries.